All right, welcome back. Mr. P helps with Calculus Unit 4, Day 6. Solving problems with related rates and using implicit differentiation. I know I usually skip going over the warm-up, but this one's kind of important because it's been a little while, a few videos since we did implicit differentiation. Remember, differentiating with more than one variable. All right, when you look at this, the first thing you should notice is that this is product rule. So we have 2x being multiplied by y squared. And remember, when you differentiate anything that's a y, because you're doing it with respect to x, that's going to be dy dx. You always have to put those units at the end. Whereas if you are differentiating anything with x, dx dx, it does not need to be there. It's dx divided by dx would be itself. All right, now looks like when I did these notes, I used the constant multiple rule and I pulled out the 2, but you really don't have to do that. You could do it like I just did, like I wrote up here, which is using the product rule, and it's going to give you the exact same answer. Just make sure that when you do the derivative of this, derivative of 2x is going to be just 2. So don't forget about that. All right, but you can pull out the 2, and that will not change anything. Just using product rule, first times derivative of the second, plus the second times derivative of the first. Derivative of 2 would be 1. So I don't usually put the 1, but it'd be times 1 right there. Derivative of any constant will be equal to 0. That's where that came from. And then I just multiplied everything by 2. Like I said, that'll give you the exact same answer as if you did it with the 2x to begin with. All right, then it's just a matter of getting dy dx by itself, if you remember doing that. And then we're going to solve for it by dividing both sides by 4xy. And the whole point of this was to simplify it down so that we have the simplest answer for dy dx, the derivative of y, how y is changing with respect to time on the x. Now, we're going to be using that implicit differentiation to do what's called related rates, which basically means we have word problems that involve more than one variable. And a lot of the times, AP Board likes to use equations that you already know, like using the Pythagorean's theorem. A squared plus b squared equals c squared is a very common one that you're going to see. And there's a lot of geometry formulas, like on this very first question, is talking about the circle. The radius of a circle is increasing, so you know the area of a circle is pi r squared. All right, so getting back to the question, it says the radius of a circle increases at a rate of 2 inches per minute. Find the rate of change of the area when the radius gets a size of 6 inches large. So let's start with, what formula do I need? They're not usually going to give you a formula. Now, I guess it's possible, but it's very unlikely. So you're going to have to come up with a formula. In this case, we know we're dealing with the radius of a circle. That's area of a circle. So that's area equals pi r squared. And then what I like to do is I like to list out. This is just a list of all the information they gave me in the question. So I list all that information out, and then I use it to plug in to solve. So let's just start with focusing on what do they give me. The radius is 6. They also told me that the rate at which the radius is changing, that's dr dt. The derivative of the rate with respect to time happened to be 2 inches per minute. Now, what we're going to do now is differentiate both sides. We're going to take this equation, a equals pi r squared, and we're going to differentiate them in terms of time, because that's what this is. This is in time. All right, so derivative of a, that would be the left-hand side, derivative of a with respect to time, is equal to, 2 times, that's simple power rule, 2 times pi times radius. So when you do pi r squared, remember pi is really just a constant, so it's really just constant multiple here. And then multiply that by dr dt, because remember, the derivative of r would be, derivative of r squared would be 2r dr dt, because that's the derivative of r with respect to time. Then, once I've found the derivative, which I already did, I did it in one step, now it's a matter of taking the information that I started with and plugging in everything I know. They're always going to give you all the information except for one thing. And that one thing is obviously what you're trying to find. We're trying to find the rate of change when the radius is 6 inches. We're trying to find the rate of change of the area. So we're trying to find dA dt. We're trying to find how the area is changing over time. Well, they gave us all the information except for dA dt. So this is perfect. We can just plug in our numbers, multiply across. 6 times 2 times 2 is 24 pi. I would leave it in terms of 24 pi because otherwise you're going to have to round and then it's not really an exact answer. So just leave pi in your answer. would be preferred. Otherwise, if you're going to multiply by pi, make sure you use 3 significant digits. And there's your units. I always tend to focus on units at the end. And if you think about it, it's just easier this way. Now, you could plug in 2 inches per minute, and you end up multiplying it by 6 inches as well, which is the reason why it's inches squared per minute. Now, for this question, I could see it's easy if you would just put the units with the numbers. But me personally, I think, going forward for all the questions, that it's easier just to think of what the units are at the end. If you think of area, area is in terms of inches per minute. And then you know you're dealing with the rate of that, so you know you got to be dealing with inches squared per minute. All right, question number 2. The length of a rectangle is decreasing at a rate of 5 centimeters per second, while the width is increasing at a different rate of 10 centimeters per second. If we know the length is 8 and the width is 12, find the rate of the change of the 2 following things. So they're asking us, this is really 2 questions, to be honest, using the same information. So the first thing I did was identify what they gave me, dl/dt, that's the rate of the length with respect to time. And they also gave us the rate at which the width is changing over time, which was 10. So that's the 2 pieces of information they gave us, plus they told us the length and the width size. And then find the rate of the area. The area of a rectangle, pretty easy, length times width. We differentiate it, dA/dt, everything's with respect to time in this case. Notice this is product rule, length times the derivative of width, plus width times derivative of the length. And then once you've done that, then you start plugging things in. Now, in the last question, I said they're always going to give you all the information except for one thing. That won't always be true. There will be some times where you have to solve for some particular information. I don't know why I'm bringing that up, because that's not a part of this question, though. They actually did give us everything we need. They gave us the length. They gave us the width. They gave us the rate of change of the length and the width. So all that information is right here in the question. Then it's just a matter of multiplying it across, and that's how we got the answer of 20. And since, once again, we're dealing with the rate of change of area, area is always units squared. So that's why it's centimeters squared per second. It just makes sense. Area is always units squared. But if you wanted to, you could always put the units, and it does work out both ways. I just think it's easier and cleaner to do these related rates questions if you just do them without the units, and then just think about it logically. You can always figure out what the units have to be at the end based upon whatever they're asking of you. All right, perimeter is one-dimensional. So obviously the units on perimeter isn't going to be units squared. So when I get to the end, I know it's just going to be units per second because it's a one-dimensional distance around the shape. All right, so we start off with this formula for perimeter, which happens to be 2 lengths plus 2 widths. That's the distance around the shape. We differentiate it. Derivative of p is dp dt. Derivative of 2 times L would just be 2. Same with 2w is derivative just 2, but don't forget you got to have those units. Derivative of L is dl dt. Derivative of w is dw dt. Now, they gave us, once again, a lot of this information, but not everything. They didn't give us the perimeter. So they plug in the numbers that we know. We just substitute them in, solve across, and there's where our answer comes from. It looks like the perimeter at that moment is increasing by 10 centimeters per second. Now, of course, this is not going to be the rate of the entire time. It just happens to be at that specific moment. All right, example number 3, our last example. Let's see. V equals I times R. V equals the volts. I equals the amps. And R equals the ohms. Given V is increasing at a rate of 2 volts per second. Okay, that's information. That's the rate at which volts is changing. So that's dV dt is 2. I is decreasing. That's important. So it's got to be negative at a rate of 3/4 per amp. So di dt is negative 3/4. Find the rate at which, okay, so we're trying to find dr dt, it looks like, change when volts is 24 and I, which was the amps, is 6. All right, so this is all the information they gave us from the beginning, and we're trying to find dr dt. That's what we're trying to find. All right, so they gave us the equation this time. That won't always happen, but they did. This is product rule. Can't forget about that. Again, another product rule question. So that's where I got this from. I plugged in all the information that they gave us, Slight difference from the last question. This time, we're going to have to use our algebra skills to find DRDT because it's not on the side by itself. So we plug in the numbers, use your algebra skills, add 3 to both sides, divide by 6 in the end, and there's where we get our answer of positive 5/6 ohms per second. That is the rate at which the ohms is changing at that exact moment. All right, I'm sure we're going to do some more practice of, you see these related rates questions all throughout the year. This is one of those questions you can almost guarantee is going to be somewhere in the FRQs on the final, on the AP board test. So this is just one of those things that you're going to see. It's very, very common. You can almost guarantee that it's going to be on that test. Thanks again for watching, and I'll see you on the next video.